All right, so up until now, I think I've only ever done videos showing you how to use pixel processor, to just do straight up animating, panning, etc., in substance materials. But you can also use it to make sprite sheets. Let's just make a new substance. I'm going to go ahead and make an empty graph. And this first one, we're going to see how we can use a function to create a grayscale grid. And we can use this for a bunch of different things. I'm just going to create an output node. And I'll call it output. And we'll set this to any because it's not really something that we're going to use in a material. And this, it's just multifunctional. And I also want, since we are going to be making sprite sheets, I'm going to get out ahead of this and I'm going to create an input parameter for my grid size. So I want to be able to determine, how many across and how many down my sprite sheet, the grid on my sprite sheet is. And we're going to use integers for this, and we want 2 points because we want whole numbers. And I'm going to set my default to 6. So that'll be our maximum, and we'll also set the maximum to 6 and set that as true because I don't really want, well, I mean, you can do these numbers however you want to do them. But that's how I'm going to do it. So I've got that variable set up, and I want to actually get into my pixel processor, and we're going to do a function in here that is going to split up the texture plane, if you will, into a series of grids that'll correspond to whatever we've put in with that variable. So let's go ahead and get that. And that's integer 2, and we can set that to our grid size. And we wanted this as an integer because we really want whole numbers. But ultimately, we're going to want it as a float too. So I'm going to get cast to float 2, and that's just going to convert those 2 integers into a float 2. And then, since we are allowing this grid to be non-square, so you could set it, 4 to 6, whatever. I want to be able to manipulate both the x and the y values separately. So again, I'm going to come in here, I'm going to vector swizzle float 1. I'm going to copy this and paste this. And I'm just going to, well, we'll have the x up here, and then I'm highlighting this node, and I can actually tell it where, what I want to swizzle out. So I'm going to swizzle out the y on that one. And that breaks it up into these 2 separate pieces. Now, in previous videos, I've said that whenever you're doing a pixel processor, it's going to absolutely need 2 things. It's going to need a $ position, and it's going to need a sampler. That's kind of true most of the time. It only really needs a $ position because what we're doing here, and that's a float 2 result, we're creating something that doesn't in and of itself have an input bitmap. This is something that we're going to actually create. This is almost like a little engine that we're making, and we're going to actually use this within a second pixel processor. That's in this pixel processor that we're making right now is going to feed instructions to a second pixel processor, which will have an image input. So, I mean, like a sampler. So right now, I'm just going to get a $ position, And I'm going to do exactly the same thing to this that I did to this float too. So we might as well just go ahead and copy these two, paste them out. And instead of having it being off the grid size, we're going to have it be off the $ position. And then we're going to actually hook them up together so that they're working in tandem by using multiplication node. So the X with the X and the Y with the Y. Now, let's take a look at what we've done so far. This is the 2D image. So far it's a big 0, which is black. Now, what happens if we set this as our output node? We're beginning to see how we're splitting this up. I've set this as my output node. So we're talking about my X. Now you'll notice that this is actually moving along the Y valley, but what we're talking about here is how am I splitting up my X axis. So it's getting split along the Y. So it's actually kind of looks backwards, but it depends on the way you're looking at it. But the thing that's happening here is we're actually getting a gradient, and that's not what we want. We want hard edges. And in order to get that hard edge, right now what's happening is that because this is a float, it's looking at all the various numbers between, you know, whatever this value is and the next value up. There are, you know, at least depending on how you're splitting it up, you know, there's 1.1, 1.2, 1.3, 1.111, you know, so there's a lot of points in between here that we want to get rid of. And the way we're going to do that is we're going to come into the library and we're going to type in floor and we're going to pull out one of these guys. And what this does in a nutshell, it strips out everything after the decimal point. Why don't we just go ahead and copy this and make a new one, and we'll do one for each of them. But if we move this now to the output node, it's literally gotten rid of all that grayscale. So if it's a number between 0 and 1, so it's like 0.1, 0.2, that's going to show as 0. The minute you go over like 1.1, 1.2, that's going to show up as 1, and all the way down the line. And there's another one that's called ceiling, which does it in the opposite direction. So, you know, if you wanted to do it the other way around, you would do ceiling. And if we set this as our output node, it's just going to do the same thing, only now it's splitting the Y value along this way. So now, if we add these two guys together, what we end up with is the definition of what one of our grid squares is. So if we come back to our input parameters, and we start moving these around, we can see that as we change our grid size, so the X, our X is getting Y, you know, where we now only have 2 on the X. Now we have 3 on the X, 4, 5, 6, and the same thing with the Y. So now we're, you know, that each one of those represents just the one square, the square size. So now the next thing we need to do is we need to kind of multiply this and have it work along the grayscale. So now what we need to do is we need to take our Y value and split it up according to the number of grid spaces that we put in on the X. So we'll get a multiply node, and we just multiply these two values together before we add them in. So that's just going to split it up. And finally, you don't see any difference here. We actually have to do one more thing to it. We finally have to take that whole result and divide it by the total number of squares that we have. And we just multiply these two values together before we add them in. So that's just going to split it up. And set the output node, and that gives us a grayscale progression going from black to white in the direction of a sprite sheet. And then as we come back in here and look at our input parameters, we can change the size of this grid. So this is actually something that's really useful to have in our library. So just hook that up, that output. That's why we were having that yellow mark. This is just that's the one that we start out. We'll just get rid of this one. And the reason we had that sort of warning sign was because there was no output selected. In order, it needs at least one output, and we just didn't have it hooked up. So the second we hooked up that output, that little warning sign went away. And now we can save this to our library, and we'll just put in our demo workspace, and we'll save it in there. And we can use it to nest into the next thing that we're going to make for our sprite sheet. Yeah, I just noticed one more thing before we start our new graph. We need to change this result to a grayscale, so I'm just going to go ahead in here and change that pixel processor to a grayscale. Otherwise, it's not going to work right. So File, New Substance, and this one we're going to call Offset. And again, we can leave it empty and just go ahead and make a new one. And you'll notice again, we're getting that until we put an output node in here that actually has something connected to it. No, it doesn't care that it's connected. It just wants an output node. And we're going to set it to any. There we go. And first things first, let's just bring in this grayscale grid that we made. So it's got that grayscale output. And we're going to set this up with, we're going to use this grid along with a grayscale image input. In other words, the result of this, what we're making here now, is going to allow the end user to input any grayscale image. And then we're going to run that through this pixel processor. Let's remember to change that to grayscale now. And we're going to use both of these within the process that's going to go on in here. So you notice that as I hooked up this input here, it created a second one for me here. And I'm going to hook up this grayscale input image to input image number 1. So we now have two things that we're going to be fooling around with inside this pixel process. Let me just set this into my base color. So let's come in here. We're going to edit the pixel processor. We're going to get rid of that. And here we have our grid size. I want to use this same grid size for everything that we do here. So I'm going to go ahead and expose it now, just as is. And then the other thing while we're out here making instance parameters is we are going to need to create an offset. And why don't we come down into, this is frustrating. Oh, we're in the wrong thing. Yeah, let's look in here. And we will make our offset. And it's going to want to be a float too. So we'll reset that and call it offset. So now we have our default I'm going to set as 0. And the minimum, this really depends on, how much you want to offset it. But I'm going to give it 5 in either direction. And I will clamp it. Again, that's entirely up to you. So we've set up our input parameter. We can come back into our pixel processor and start grabbing up some variables. We know we're going to need a position because it's a pixel processor, so that's our float 2. And then our grid size we had as a integer 2. So we can come up in here and get our grid size. And again, we did that because it's easier to keep it whole numbers. And let's go ahead and cast that to a float 2. So we're dealing like with like here, and there's no reason to, like we were splitting it out earlier, we can just go ahead and multiply these the way they are. So multiplication, and we can hook those up together. So we've attached our position, $ position, to our grid size. What we haven't done is hook it up to that grid that we made in the previous graph. And to get that, we're going to need a sampler. So it's a gray. We can sample the gray. And now, once we've got more than one input in here, it will give us a drop-down list with a choice. So the grid is input image 0, so we're going to go ahead and use that. But now, you'll notice, again, we're dealing with float 2s here. This is actually a float 1 result. They could have picked better colors, but this is a brighter green than this. So they're calling it 2 different colors. It's not the most user-friendly. But we are going to have to get out a float 2 out of this. So we're going to come in here, vector swizzle float 2. And now we've taken this float 1 value and swizzled it out to a float 2. However, this has only got an x value in it because it's a float 1. So I'm going to swizzle out an x on either one of these variables. And then all we need to do is bring in our offset. And multiply it by the result. So this here is offsetting the grid that we made in the previous graph. And then to hook them all together, we just add them. Now, the one thing that we haven't done here is, we've made the function, but we actually have to apply it to something. And that's where that other input variable comes in, because we are actually going to set this as our output node. But instead of being input 0, which is our grid, we're going to set it to input image 1, which currently is nothing at all. But what that means is that once we've saved this out, that whatever input image gets put in here will have this process of taking our grid that we made in the previous graph and then offsetting it according to that grid. So let's go ahead and save our offset. And now we can bring it all together in a new substance where we're just going to make a super simple smoke sprite. This isn't about making sprites. This is about getting those grids to do what we wanted them to do. So let's just save this as smoke sprite. And let's bring in our offset. And before we do anything else, let's just go ahead and expose the parameters that we've already made. Okay, so now we can use the same grid size and the same offset in the actual sprite sheet. So the first thing we're going to want to do is to set up the grid, if you will, just like we did. In other words, we want our grids to match up. In the substance library, there's a tile generator. There we go. And so we're going to go ahead and use that. And if we take a look at the parameters of the tile generator, we can do a bunch of different things. First of all, we're going to want to pick out, this is really irritating. I'm used to working with two screens, and I only capture one for videos, and it's really cramps my style, so I complain. Again, I like Thorn here, but this call is up to you. So we're not going to spend a lot of time on this. I do want it bigger though. So let's come in here and increase the scale somewhat. And then the other thing I want to do is I want to set the, I want to actually change this so that it doesn't, that this matches up with what we've been doing. So whenever we change the grid amount, this needs to change, and it needs to change accordingly. So we're actually going to have to create an empty function for that, well, for both of them. And it's pretty straightforward. Again, we know where, oh, it's an integer. I keep doing that. Get integer 2, and this is our grid size. But we want to have a float 1 result because it's dealing with the way that this tile generator deals with it is it's actually dealing with the x and the y values as separate entities. I keep losing them. There they are. So if we come into here, you can see expected output type is an integer 1. It will always tell you this, so if you're ever not sure. So we need to split this guy up into integer 1. So we're going to swizzle integer, where are we? Integer, swizzle integer 1, there we are. And this is for the x amount. And we're going to set this as our output node. And then we're going to come back in here and we're going to do the same thing to the y amount. So, why don't we just come up in here, copy it, come in here, paste it, and then just change this to y and set it as our output node. So now it's not going to go above 6 because that's the maximum. So that was our default. And if we come back into our graph, we can see that this is now working according to everything else. So they're all working on the same variable, so this way it's all going to, everything matches. Right, so let's figure out what we're going to put into here. I think maybe, again, we're not going to concentrate on making noises here. This is about the mechanics of getting the pixel processors to work for you. So I'm just going to pick out a couple of things here, and we'll just quickly put something together. Let's get a blend node, blend those up, maybe with multiply. And where's my Perlin noise? I'm going to bring that. Okay. And maybe bring in a levels node so we can adjust it later. And another blend node. And then we can start chopping up our little sprites. So here, what we can do is now, instead of just doing it like this, we can put in this offset grid in here, and then we could actually make a copy and do another one, and set these in to each one of these. And it's taken, what it's done is it's taken this whole image, this whole image, and it makes a tile for each one. So let's get this adjusted before we go any further. So I'm going to bring this down and I'll make it much bigger. Like that. And then we can, no, I think I'm going to bring this levels node. I'm going to put another one in here. So I want to look at this. Actually, I want to look at this. And come back to my levels. Maybe get a bit more of a contrast. And let's get an output node. Now let's see what happens when, and that's a nasty looking sprite sheet. I'm not very happy with that. I think if for our purposes it's good enough. Right now, each one of these guys is exactly the same. And that doesn't make for much of an animation. But if we come in here and look at what we've done with our offset, we can see that as we set this, it's taking the same image and it's slightly offsetting it as it runs through this animation. Now, this is really messy because we'd actually have to come back in here and make these a bit smaller because I'm seeing what looks like overlap. You know, they're not discrete images. But like I said, this isn't about learning how to make good sprite maps. This is learning about making that little engine for yourself, because once you've done this, it's probably a bit cleaner. Once you've done this, you can actually, you can offset both of these because we put it on. We put it on both of them, so it's offsetting them both at the same time. And as we move them, then you get the changes you want. The reason it's going back to 0 is because I'm not hitting apply for my. If I want to switch back to the other mode, it's going to, unless I hit apply, it's actually going to bring it back down to what my original defaults were. So that's basically it. You know, you can once you have this little offset machine, you can actually use it for any sprite you make. So that's kind of nice. Oh, one more thing, just quickly, just to give you ideas, another way that you can use that little grid, the original one that we made, is you can also use it to colorize stuff. Don't forget, if you want your animation to actually scroll through colors, you can get into a gradient editor. You plug it into a gradient map, and come on, and you can assign colors to these spots on the gradient. I don't know why it does that. It shouldn't do that. Oh, because there's a black there. That's why it's doing that. Okay. And now you can actually apply this if you wanted to. Instead of the grayscale, you could have your thing go through colors as well. So there's a couple of different uses for this, and it's actually really handy. And that's something different that a pixel processor can do. So I hope that's been helpful.